Hello again, everybody. Welcome back. We're going to be doing section 4.6 today, and it involves solving equations with exponential and logarithmic equations. Once again, I think this is an important topic for you. Perhaps right now you're saying, well, why are we doing this? This is pre-calculus, and in calculus you are going to want to be able to solve these logarithmic equations and exponential equations. So really the only two things that are, they're not even new, that we're obeying here is the two laws. Here's one equation, an exponential equation. If the bases are equal to different exponents, you just set the exponents equal. 2 to the third, and vice versa. And towards the end of the examples we're going to do, there's a log equation. You know, if the bases are, again, the bases have to be same, if and only if m equals n. They have to be equal. And this IFF means if and only if. It goes this way to this way and this way to this way. So essentially, we're just going to use the last section, all those properties, to get equations in this form, and then just set the exponents equal to each other, or vice versa. And the way we're doing that, I have examples. Hopefully these are quick. These are just examples. And I think the rest of this video is just a bunch of examples. 2 to the x, you know. I shouldn't have 2x plus 3 or something. I don't know. But here, x plus 1 equals 2x plus 3. X equals 2. There you go. That's an example. Let's skip at 8. 8 to the x plus 2. 8 to the x plus 2 equals 16 to the something. X plus 1. And so there's something like this. Well, we want to get to the same base, so you can't do anything there. But we can express this 8 as 2 cubed, so it's 2 to the 3x plus 2 equals 2. This is 2 to the 4th. X plus 1. And so we're just going to say 3 times 3x plus 2 equals 4 times x plus 1. I'll go over here. Right. I'm just setting the exponents equal to each other. 3x plus 2 equals 4 times x plus 1. And you can see why you want to do this. The algebra is heavy. It's really going to be good for you in calculus. 9x plus 6 equals 4x plus 4. 5x equals negative 2. X equals negative 2. So, you know, that's what we're doing. You just make it and you just do the algebra. And there's a lot of algebra involved in this particular section. And now suppose, yeah, one more perhaps. I don't like any of these actually. Yeah, so let's just suppose, this is, you make the bases the same. Suppose the bases are different and you can't make them the same. Well, now this truly is important because this is what's going to happen to you next year. For example, how do you solve this? To the x. We want to solve that. Solve for x. You know, how do you do that? Well, right now you can't. However, because of logarithms, you can. Because there's a property of log, say you can take a logarithm on both sides, and we use the natural log. And there we go. And now, because of the properties of exponents, this comes out. X plus 2 times ln 5 equals x times ln 4. Hey, I'm going to multiply this out. Ln 5 plus 2 ln 5 equals x ln 4. And then now to solve this, we did this. You have to get the x's on one side and all the numbers on the other side. So I'm grouping these two together. X times ln 5 minus x times ln 4 equals negative 2 ln 5. And the reason I group them together is I can factor out x. ln 5 minus ln 4 equals negative 2 ln 5. And then divide. Boy, oh boy, these are long. These are algebraic. So I'm dividing by this. X equals, let's see, negative 2 ln 5 over ln 5 minus ln 4 more properties of logs right here. X equals, let's see, this is ln 1/25. That's the numerator. The denominator is ln 5/4. Therein being able to get a number. You can do this on a calculator. I have a couple of these done on a calculator, not this one. But you can do that then on a calculator and get some kind of number for this x. So we solved it. Point is, a lot of algebra. And the rest of what we're doing is examples. So it's going to be a lot of algebra. How about, I don't know, 4e to the, oh, yes, 2 to the x equals 3 to the x plus 1. 2 to the x equals 3 to the x plus 1. Solve. Well, you can't. You know, you can't without like basis, but you can with like logarithms. So I can take a logarithm. I can raise each side of the equation to the natural log. First thing you do when the bases are different. And you'll do that over and over and over again. That's why this particular function is really important. And now it's x. ln 2 equals x plus 1, ln 3, and you know, it's a lot now like this problem. The algebra goes on. Going to multiply out the x's. Right? Subtract x ln 2 minus x ln 3 equals ln 3. I'm putting this in a single, well, factor out the x. ln 2 minus ln 3 is ln 2/3. And there you go. Just divide by ln 2/3. X equals ln 3 over ln 2/3. And again, you can do that on a calculator. And you'll get an actual answer. Oh, hold. This answer is going to be negative 1.5 maybe or something. 2.5, yeah. Okay, but in order for this to be true, the answer has to be, x has to be a negative. You check that out. Okay, suppose there's an e in the equation. Another example. Suppose there's an e in the equation. How about this? 4e to the 2x plus 5 equals 12. Plus 5 equals 12. Well, first off, this plus 5 stuff, that's superfluous. You got to get rid of that. 4e to the 2x equals 7. Furthermore, e to the 2x equals 7/4. Now we take the ln of both sides. ln e to the 2x. These two are inverses. ln e to the 2x from last section means 2x. ln 7/4, and you can do this on a calculator. ln 7/4 divided by divided by 2, excuse me, divided by 2. Okay, so now let's go backwards. Let's work with log equations. For example, hang on a second. Ln x squared equals ln 2x plus 3. Ln x squared equals ln 2x plus 3. Only if the arguments are the same. So we could go right to saying x squared equals 2x plus 3. And then there's a quadratic. You solve a quadratic. X squared minus 2x minus 3. X minus 3, x minus 1, plus 1 rather, x is 3, negative 1. Whew. There's that one. Let's just skip to the last one more example. I understand this whole tape, this whole video has been examples. There's only 2 concepts in this particular section, but with that said, this is important. This is important for you to practice for your success in calculus. That's what's important. Okay, just this one. Ln x squared minus 10. Ln x squared minus 10 something equal plus a ln 9 oops, this is going to take the rest of the board, I think, equals ln 10. Where do we get this? Alright. First off, I'm going to put all this stuff together. This means ln 9 times x squared minus 10 equals ln 10. And then we just raise them both. Or x squared minus 10 equals 10. Why the tens? I wonder where I got this example. I don't know, but it will just follow through. Minus 9 equals 10. 9x squared equals 100. X squared equals 109. X plus or minus 10 thirds. Whew. Never let it be said that it doesn't help to be quick when you do algebra. I understand how fast that was, but that's it for this section. We're just doing examples. It's algebra, algebra, algebra. Hey, see you next time. Good luck.